Hi, this video is about density. So we're going to be using some numbers. So we want to keep in mind to use sig figs properly throughout this video. All right, this video, like I said, is about density. Density, I like to think of it as a way to convert between mass and volume. So first of all, let's make sure that you know the definition of density. The definition is density is mass divided by volume. And the way I remember this, it's kind of silly, is I just love density. See my heart? Mass over volume. See the M? See the V? All right. Well, on your reference packet, they also give you this formula. Density is mass over volume. So here's the deal. You have two variables. All right. If you know the density and you know the mass, you can solve for the volume. Or if you know the volume and the density, you can solve for the mass. And if you know the mass and a volume of something, you can solve for a density. So a lot of times density is a way to identify something when you don't know what it is. So they might say, hey, you've got like 10 grams of this stuff and it has a volume of 5 milliliters. What is it? And so you would calculate a density, and then there are tables and tables of densities of different things, and guess where we're going to find them? We're going to find them in our reference packet. As a matter of fact, there are two different tables with just density data in them of substances. So if you calculate a density, you can identify something, so that's important. Density is what we call an intensive property, and what that means is it doesn't matter how much you have. If you have a whole bunch of gold, the density is the same as if you had a little piece of gold. And this is important. Density changes with temperature. So if density is mass divided by volume, mass isn't going to change with temperature, but the volume will. And generally, things will expand as temperature goes up. So as your temperature goes up, your volume goes up, but what would that do to your density? It would make your density go down. So typically at higher temperatures, things are less dense. All right, well, let's look at a problem. All right, now one way to measure density is by what we call water displacement. And so here's a table of some values. Okay, so you've got an unreactive metal. That's good to know because some metals react with water, remember from that activity series. So we don't want to put something that's going to react with water, but this is an unreactive metal. So it's something in the activity series that's lower than water, and you drop it into a graduated cylinder. All right, now the mass of your metal is 19.611 grams. You had a pretty precise balance to give you 3 decimal places. Well, the water in the graduated cylinder was 12.4 milliliters before you plop the metal in there. I just want you to, imagine in your mind, here you've got this graduated cylinder with 12.4 milliliters of water in it. Drop in a piece of metal. It doesn't have to be like any specific shape. It can just be a blob of metal. And what's going to happen to the volume of your water? It's going to go up. That is because of water displacement by the metal. And now after you plop your metal in, the volume of your water is 14.9 milliliters. The density of the metal is going to be reported in grams per milliliter. And let's go ahead and see what we get here. The density is 19.611 grams. But what is our volume of our metal? Well, the volume of the metal is the amount of water that was displaced. And so the volume is 14.9 minus 12.4. It's 2.5 milliliters. So see, this volume went up by 2.5 milliliters. That means the volume of the metal was 2.5 milliliters. Now, when we do this math, and this is 2 sig figs here, and this is 5, so this is a division problem. We're going to have to report our answer to 2 sig figs. So should we report it? If you put it in your calculator, you're going to get 7.8444. But that's too many sig figs. So the right answer is right here, 7.8 grams per milliliter to 2 significant digits. Okay, we're actually going to determine the density of some metals by water displacement in the lab tomorrow. All right, we can also use density as a tool to get a volume or to get a mass. All right, so here we go. Let's try this problem. So I'm going to start with my density formula. Density is mass over volume. And then I'm going to plug my numbers in the proper places. All right, what is the mass of 75 milliliters? 75 milliliters, that is a volume. Milliliters is a volume. The density is this, 0.879, so that's our density. And they would like to know the mass, and that's an M. Okay, so let's plug these numbers in. We've got 0.879 grams as our density. Grams per milliliter is equal to our mass, that's what we're looking for, divided by 75 milliliters. Solving for M, and it was 75.0 milliliters. That's important. All right, solving for M, it's going to be 0.879 grams per milliliter. And doing the math, we cross multiply times 75.0 milliliters. This unit milliliters is in the numerator. Down here it's in the denominator. We're left with the unit grams, which is what we want. And when we do that, reported to 3 significant digits, I get a mass of 65.9 grams. Again, notice to 3 sig figs because that's 3 and this is 3 sig figs. All right, let's look at this problem. The density of liquid mercury is 13.6 grams per milliliter. It's a very dense metal. It's the only metal that's a liquid at room temperature. Okay. All right, so that's our D. Wait, 13.6 grams per cubic centimeter. All right, a cubic centimeter is centimeters cubed. It's called a cubic centimeter. All right, have you ever heard, like on doctor shows, or if you've ever been at the doctor, they might say, I need 5 cc's of that. cc stands for cubic centimeter, and it's a volume, and it's used in the medical field a lot. And a cubic centimeter is exactly the same as a milliliter. So a cubic centimeter, don't let that centimeters cubed scare you. It's a milliliter. Okay, they would like to know the volume of 100 grams of mercury. All right, well, our density is 13.6 grams per cubic centimeter. Our volume is what we're solving for, and our mass is 100 grams. Okay, so here we go. Density, 13.6 grams per cubic centimeter is equal to 100 grams, our mass, divided by our volume, which is what we're solving for. Now we're going to cross multiply here. So it's going to be 13.6 grams per centimeters cubed times volume equals 100 grams. So our volume is going to be 100 grams, that's 4 sig figs, divided by 13.6 grams per cubic centimeter. The grams cancel, we're left with cubic centimeters, and I'll put the final answer up here. It is 7.35 cubic centimeters. And that is our volume. Okay, and we were reporting that to 3 sig figs because 13.6 is 3 sig figs. All right, now, sometimes in problems, people think, wait, they're giving me a temperature. Am I supposed to use that number? And you're not in a density calculation. But what that temperature is, it's making your density complete because densities change with temperature. So like we said earlier in the video, typically the volumes expand as your temperature goes up, which would make the density go down. And so this is just data for water at 4 degrees. So that's pretty chilly, 4 degrees Celsius. The density of water is 1.000 grams per milliliter. At room temperature, at 25 degrees Celsius, the density goes down to 0.99707 grams per milliliter. And if you are at a very high temperature, so if you're at 100 degrees, our density, if you're still in the liquid form, is 0.95838 grams per milliliter. So really, the density of water is right around a gram per milliliter if we round those. All right, so we're going to practice doing some calculations with density, and we're also going to get the density of some metal pieces using water displacement.